I'm going to walk you through the problems on the Keep on Reviewing for Exam worksheet. Number 1, when I see that I've got square roots top and bottom, and I see that there's addition sign in the denominator, in order to rationalize the denominator, I need to cancel out the square root. And so I do that by multiplying the top and bottom by the conjugate of the denominator. So I'm going to multiply by 2 minus square root of 3 on top and bottom. Think of this as a group because of the addition and subtraction signs. And so now I need to distribute square root of 3 times 2 and square root of 3 times minus square root of 3, which is square root of 9 or just 3. On the bottom, 2 times 2 is 4, 2 times minus square root of 3 minus 2 square root of 3. Then the next term, square root of 3 times 2, and square root of 3 times minus square root of 3 becomes minus 3. If we did this correctly, the minus 2 square root of 3 plus 2 square root of 3, those should cancel each other out. They equal 0. And so on the bottom we're left with 4 minus 3, which is equal to 1, and dividing by 1 doesn't change the value of the top. So 2 square root of 3 minus 3 is simplified form. Number 2. So anytime I see a square root divided by another square root, if these aren't obviously perfect squares, I want to simplify the whole square root first, the fraction. So 24a to the 5th b is being divided by 54 ab to the 3rd. And so I want to simplify this fraction. 24 and 54, I want to reduce it. And I notice that each of those can be divided by 6. So 24 divided by 6 is 4. 54 divided by 6 is 9. I see that there are 4 more a's on top than there are on bottom. So I have a to the 4th on the top. And I see that there are 2 more b's on the bottom than there are on the top. And so I'm left with b squared on the bottom. And so now all of this is inside the square root. So I'm going to go back to taking the square root of the top and the bottom. And so now I can do square root of 4, which is 2, square root of a to the 4th, and so it's 4 divided by 2 is a squared. It's how many a squareds can I put into a to the 4th. And on the bottom, square root of 9 is 3, square root of b squared is b. So 2a squared over 3b is my solution, or simplified form. Alright, number 3, we are multiplying functions together. So I replace f of x with its expression, 9x minus 5, and I'm going to multiply that by the expression for g of x, 7x plus 2. And so when you multiply functions together, we distribute 9x times 7x, 63x squared, 9x times 2, 18x, minus 5 times 7x, negative 35x, negative 5 times 2, minus 10. Then I'm going to look for like terms. And so my simplified form is 63x squared minus 17x minus 10. In number 4, we see an example of composition. So composition can be written as g of f of x. So we're inserting function f inside of function g. So if I find my function f, 9x minus 5, I want to insert that in place of x in g. So 7, and now instead of x, and then plus 2. So I'm replacing the x with f of x, 9x minus 5. Distribute the 7, 63x minus 35, and then minus 35 plus 2 is minus 33. Logarithms. There are 4 rules. One is just being able to transfer this logarithm into exponential form. So we set it equal to x and then rewrite it. The little number, the base of the logarithm, is the base of our power. The x becomes the exponent. And then 128 becomes what the exponential function is equal to. At this point, I want to refer to my exponent worksheet because I need to figure out how to write 4 and 128 using the same base. So if I look at my exponent sheet, I see 4 to some power never becomes 128, or not with a whole number. But if I look up another line, I see that 4 and 128 are both powers of 2. 4 is 2 to the second power, and 128 is 2 to the 7th power. So I want to rewrite 4 as 2 to the second power, and just keep that x in your exponent. And then 128 is 2 to the 7th power. So for these two to be equal, the exponents have to be the same. So that means 2x needs to equal 7 divided by 2, and x could either equal 7 halves, or 7 divided by 2 is 3.5. And so log with base 4 of 128 is equal to 3.5. The other rules come when we try to simplify a logarithm. First rule is that if you have a coefficient, it can always come back as an exponent inside the logarithm. So we can rewrite this as log with base 2 of 4 to the 3rd power. Okay. The last two rules deal with adding or subtracting two logarithms. In this case, we have subtraction with the same bases of the logarithms, and so we can combine it into one logarithm by taking the first log, 4 to the 3rd power, and dividing it by the second log, 6. So if we rewrite that, log with base 2 of 64, 4 to the 3rd power is 64 over 6. And we could reduce that fraction. Both of those can be divided by 2, so 32 over 3 is the simplified single logarithm. Now if this had been addition instead of subtraction, we would have multiplied 4 to the 3rd times 6 to find what goes inside the logarithm. Okay. Number 7, state the transformations. So there's two things that changed from our original 3 to the x function. 3 to the x there's a plus 2 in the exponent and there's a negative in front of it. The plus 2 is going to translate or shift the graph, the function, translate 2 units, and because it's inside the function next to the x, plus 2 actually moves it to the left. So it's going to translate 2 units left. The minus sign does the opposite, and so that is going to reflect the graph over the x-axis. So it's transformation, reflect over the x-axis. That's what the negative is going to do. Okay? So if inside this had been x minus 2, that would have moved it 2 units to the right. In number 8, we have 3 to the x, but it's multiplied by 1/2, and it's subtracted 4, but this minus 4 is not in the exponent. It's outside the function. So this minus 4 is going to translate or shift the graph down 4 units. Okay, subtracting 4 goes down 4. If it's plus 4, then it's going to go up 4. Multiplying something by 1/2 is going to make it smaller, make it closer to the x-axis. Is going to shrink or compress by a factor of 1/2. It's going to be half as tall. So it's compressing if it's a number between 0 and 1. If it's greater than 1, multiplying by 5 is going to stretch it. It's going to make it taller by a factor of 5.